All right, guys, this is the backside of day 5 notes, and in number 4 it says if P has coordinates of -1/2, comma, negative square root of 3 over 2 is a point on the unit circle and on the terminal side of an angle in standard position whose measure is theta. Okay, so again, what that means, just to give you guys a visual. All right, we have a point, -1/2. So if I go over a little bit, okay, and negative square root of 3 over 2 down a little bit, they're talking about this point right here. And that point is on the unit circle where we have an angle who's in standard position. The terminal side of that angle passes through that point on the unit circle, okay? And they want to know what is the value of sine theta, okay? So this point right here that we're talking about has coordinates of -1/2, comma, negative square root of 3 over 2. Okay? Because they're asking about sine theta, we have to remember that sine theta is our y coordinate, and so we can say that sine theta equals negative square root of 3 over 2. Okay? Part B is asking the value of cosine theta, and cosine theta is our x coordinate, and so we can say cosine theta equals -1 over 2. Okay. Part C says what's the value of tangent theta, and we have to remember that tangent theta is equal to sine theta over cosine theta. Remember our little saying, where do you tan? You tan in Southern California. Okay, to help you remember. So when we replace sine theta with our answer from part A, which is negative square root of 3 over 2, now it's going to look weird because we had a fraction on top divided by, and then cosine theta is also a fraction, -1 over 2. So we're going to simplify this. It's actually pretty easy, okay? So the negative divided by negative will always end up being a positive answer, okay? And because of this both being divided by 2, okay, I'm sure you guys have heard of keep, change, flip, okay? If you keep the fraction on the top and you change the division bar to multiplication and flip the fraction on the bottom, okay, what happens is something called cross-reducing, and you can cross-reduce those 2's. So because those 2's will cancel, you can do that anytime. You don't have to think about keep, change, flip, but that's just where it comes from. Okay, and we end up with square root of 3 over 1, which is the same thing as the square root of 3. And this is what tangent theta equals. Okay, so then part D, it says, in which quadrant does theta lie? All right, so because we already graphed it, or you can just think, where is sine negative and where is cosine negative? Okay, it's going to happen in quadrant 3. Because if you think about all students take calculus, you could do that too. Notice that your sine and cosine are going to be negative in quadrant 3 because the only trig function that is positive is tangent. Okay, so you can think that way too. All right, part E is asking, what is the value of theta in degrees? What is the value of theta in degrees? Okay, so remember that we have 3 ways of solving for theta. Since we have 3 equations set up, we can use this equation to solve for theta, this equation to solve for theta, or this equation to solve for theta. And this is going to be something that we talk about, okay, guys? I want you guys to take a mental note. No matter what equation you use, just make sure that you are not typing in the negative if the fraction or answer is negative, okay? So don't type in negative. And that way they'll all come out to be the same. If you type in the negative, they're not guaranteed to come out to be the same, okay? Most likely won't. So here we go. So we're going to either type in theta equals sine inverse of square root of 3 over 2. Notice I didn't put the negative. We could type in theta equals cosine inverse of 1 divided by 2. Notice I didn't put the negative. And theta equals tangent inverse of square root of 3. Okay, if we type in any of those, theta is going to come out to equal 60 degrees. What you have to realize, guys, is that there's no way theta can be 60 degrees. That's a first quadrant angle, and we are in the third quadrant. And so you just have to realize that this is our reference angle, okay? That's what comes out. So now what we're going to do is we're going to put it in the correct quadrant since we're in quadrant 3, okay? And so we're going to do 180 degrees plus our reference angle of 60 to go more than 180 to put us down in quadrant 3. And therefore, our angle, guys, is 240 degrees. Okay, so if I go back up to my original picture, remember this red angle? Okay, that's 240 degrees that it rotated to get down into quadrant 3. And that's exactly where it intersects the unit circle. Okay, so hopefully that makes sense. All right, part F is asking what is the value of theta in radians. So we're going to go ahead and take our 240 degree answer and we're going to convert it. So we have 180 degrees over pi radians equal to 240 degrees over how many radians. When we cross multiply, we get 240 pi equal to 180x. And remember, we're solving for x, so we're going to divide by 180. And 240 divided by 180 simplifies to 4/3. And so we're going to say 4 pi over 3 radians is our value of theta. Okay. All right, guys, let's look at number 5. In number 5, it says that the terminal rate of angle theta drawn in standard position passes through the point negative 2.42, comma 0.97, which lies on the unit circle. What is the measure of theta to the nearest degree? Okay, so we'll go ahead and draw our picture. We are negative just a tiny bit and down just a tiny bit. Okay. Oop, I lied. We're up. That 0.97 is positive. So excuse me. So we are negative 2.42, so to the left, and then up just a little bit. We're actually in quadrant 2 this time. Okay, so that is a point on my unit circle. Okay, where an angle drawn in standard positions, terminal side passes through that point. And the coordinates of that point are that. Okay, so they want to know what's the measure of theta to the nearest degree. Okay, so we have 2 ways of solving this. We could find a third if we wanted to find tangent, but we don't need to. Okay, so we're going to go ahead and say that sine theta equals our y coordinate, which is 0.97, or we can say cosine theta equals negative 0.242. Okay. Now we can use either one of these equations to solve for theta. Just remember you have to use your inverse keys, so it'd be sine inverse of 0.97, or we can type in theta equals cosine inverse, and we're not going to put the negative, okay, so that we end up getting the same answer for either one of these. And that's going to give me a reference angle, always, of 75.9-ish degrees, okay? But remember, that can't be our answer since we are a second quadrant angle, and so we're going to do 180 degrees minus 75.9-ish, okay? So remember, reference angles always use the x-axis. That's why we're using 180 degrees, and the same thing in the last one, okay? And when we type that in, we end up with 104.1 ... degrees. And since they said to the nearest degree, that's going to be 104 degrees, and that's the value of theta. Okay? And if you want to double check her, you can go ahead and type in sine of 104. That should be close to the y coordinate they gave us of 0.97. And you could type in cosine of 104, and that should give you the x coordinate of negative 0.242-ish. Okay? So hopefully that makes sense. Okay? In number 6, go ahead and graph just to give us ourselves a visual. But they're saying that if m, which is square root of 2 over 2, comma negative square root of 2 over 2, is a point on the unit circle and on the terminal side of an angle in standard position whose measure is theta, what's the measure of theta in radians? Okay. So if we were to go ahead and graph this, positive square root of 2 over 2 is over to the right a little bit, and then negative square root of 2 over 2 would be down. Okay. So they're talking about this point right here on the unit circle where this angle intersects that unit circle. Okay, what they want to know is how big is this angle. Okay, so a couple things that we have to remember is that the first coordinate is our cosine, so we can say cosine theta equals square root of 2 over 2, or we go ahead and say that sine theta equals negative square root of 2 over 2. We have two ways of solving for theta, so we could say theta equals cosine inverse of square root of 2 over 2, or we could say theta equals sine inverse, but no negative, square root of 2 over 2. Okay? No matter which one of these that we typed in, we should end up with a reference angle equal to 45 degrees. But remember, that's just our reference angle. It can't be our answer because this angle is way open more than 45 degrees. Okay? We are in quadrant 4. And so the quickest part of the x-axis that we're going to go to is 360 degrees. And we're going to subtract 45 from it. Okay? So 360 minus 45 is going to give us 315 degrees. Okay? And so this angle theta is no longer missing. We know that it's 315 degree angle. Okay? However, they all want our answer actually in radians. So we're going to have to convert that. So that's not technically our answer. So we're going to have 180 degrees over pi radians is equal to 315 degrees over x radians. Okay? When we cross multiply, we'll get 315 pi equal to 180x. We're solving for x, so we're going to divide by 180. And that is a fine answer, except they are going to want it simplified. And so 315 divided by 180 math bracket to simplify that fraction ends up being 7 pi over 4 radians. And that is our answer of our angle in radians. Okay. All right, guys. So hopefully that is good. We'll do some more on day 6. I will see you guys then.